Hello everyone. I hope you all are doing good, being safe, and avoiding the unnecessary travel. Before starting with this video lecture, I want you all to, if possible, try to ignore the background disturbance of honking and the construction work going on. The topic that we have to cover in this video lecture is forces in space, also called as space forces. In this topic, we will see how to find out the force vector. For example, like in two dimension forces, that is what we have done till now. Like a force is passing between 2 points in the xy plane, then we can find out the angle theta, and then we can find out the x component of the force as well as the y component of the force by using the trigonometric functions. Now, if we have a force which is acting in three dimensions like x, y, and the z axis. So, in this case, if we have the force passing through 2 points, say A and B, and the coordinates are x1, y1, and z1 for point A, whereas the coordinates for point B are x2, y2, and z2. We know the force magnitude, say it is F. So now what we need to do is we need to find out the force vector, which is going to help us express the force in unit vectors along the three mutually perpendicular axes, that is x, y, and the z. For that, what we need to do is F vector is nothing but the dot product of the force magnitude and the unit vector along AB. Now, in this case, the force is passing from A to P. You can represent it as EAB unit vector or lambda AB as the unit vector. Now, we have already seen how to find the unit vector. Unit vector along AB is nothing but x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 the k cap divided by the under root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Now once you get the I, j and the k components of this, we can take the dot product with the force magnitude to get the force vector. Force vector is represented as F bar. So in this case, now what we have is the magnitude of the force along x direction, magnitude of the force along y direction, and magnitude of the force along the z direction. Now this is in case where we have the force passing through 2 points. What if the points are not given to us and the angle made by the force with the three mutually perpendicular axes is given to us? For that, it's like this. Now direction of the force is known, like theta x, theta y, and theta z is known to us, and we know the force magnitude. So in that case, what we will be doing is to find out the force along x direction, we just take the component of that. So F cos theta x gives you the force in the x direction, F cos theta y, and similarly for Fz it is F cos theta z. Now we already know the relation between the direction cosines is cos square theta x plus cos square theta y plus cos square theta z is 1. Now this is again one more relation that we can use. In this case, if we need to find out, just in case if the force magnitude is not known to us and we know the force components, then we can find out the resultant force or the magnitude of the force by taking the under root of fx square plus fy square plus fz square.